Need to use the right tool for the right job, and when you're delivering applications on Aussie Internet, and in particular in some of the rural areas, modern web tech like single-page apps can deliver even when the National Broadband Network, the NBN, does not. And who better to tell us about that than Geoffrey Donaldson?
Yes, Geoffrey has been developing customer-centric apps for over 2 decades. And as the CTO of Blackbox Co, hey, see that? You know, I used to work at Fresho, then I worked at Blackbox Co, now I worked at Zepto, but this is Geoffrey's thing. So he is the CTO of Blackbox Co. He's also helping to empower people by simplifying data. But the question is, does he pair?
He does. There was this one time, actually, Rails Camp, where he paired with both of us at the same time. That's actually tripling or mobbing, small mob of 3. And he said pairing with me was a great time.
What did he say about me?
You don't want to know.
Geoffrey Donaldson. Aussie Internet. How we learn to stop fearing the NBN and love the spa.
G'day. I'm Geoffrey. I'm from Blackbox Co. You can find me on these socials. We have a team all over Australia. We experience the whole range that the NBN has to offer. From the slow internet up in the northern of Queensland through to gigabit in the cities, the whole range. At Blackbox, we provide statistical analysis over cattle data to help farmers manage their herds. It's known to some as powerful bovine intelligence, or Power BI for short. Farmers have been told for years that the data is valuable and they should be collecting it. And they have been. But then they don't know what to do with it. A lot of them never have experience with technology or Excel. And they've been unwilling to part with it because they've been told it's so valuable. So our goal is to help provide clear outcomes from this data and also make it easier for these farmers to share the data across the supply chain. And we have customers all over Australia. There's some dots in places here you probably didn't think people could possibly live. But some of these farms manage over 80,000 head, or cows. So we need to be able to send enough data down to be able to render our dashboards, make them useful to some of the most physically isolated places in Australia. Fortunately, we have the NBN. So the NBN is consisted of 3 major parts. We have the wired. It's a whole own talk, and I won't even get into that. But if you do want a real rant, ask me about how it was connecting my newly built house to the HFC network. Don't get me started. I'd show you a map of the wired areas of the NBN, but at this scale, they'd barely show up. So I said, these are our customers, and these are the fixed wireless towers, which is the kind of the middle area. Not quite as good as fiber, or even HFC, but they're trying to deliver a reasonable experience. But let's take a look at this little dense patch here. Looks like a whole bunch of towers. These zoom in, and there is a lot of towers. It's a little less impressive, but each of these yellow dots is a fixed wireless tower. Very much like cell phone towers, they have a service area. But unlike cell phone towers that try until they just don't, fixed wireless have a range of about 14.5 kilometers. And this is an arbitrary software limitation. The towers are capable of closer to 30. And there's rumors that this could be updated in the near future, sometime. But I say rumors because details are a little hard to find, due to the fact that the NBN makes everybody sign NDAs. If you're going to find out if you've got availability, you've got to sign an NDA. So it's made things a little hard. So what I found out might not be the full story. There's not much I can do when the details aren't public. Anyway, these towers, at about a range of 40.5 kilometers, leaves a little bit more to be desired. And I kid you not, one of our team lives here. So, what are their options? Satellites sound cool. And they even have a cute name, Skymuster. The two satellites provide NBN to rural of Australia. It's stationed at a geostationary orbit. And they have about 5 years left of fuel at the moment. But they're stationed in a geostationary orbit is high enough, it's about 300 milliseconds away, one way. The way they work is they have 101 directional beams that break Australia up and sort of sporting islands around. And these are known as spot beams. And the data for anyone located in these areas are assigned to a specific spot beam. And those beams come up to the satellite, and then they're transitioned down to one of the 9 base stations around Australia. And then everything gets shipped back to Sydney before joining the internet. So that's a bit of a journey. Now these spot beams, they can be overlapping. So for instance, if you're in Gloucester here, you could possibly be covered by any of these 3 beams. If you manage to get beam 34, your data goes out to Kalgoorlie, and then back to Sydney. If you're lucky enough to get assigned to beam 29, you only have to go to Roma, back to Sydney. Or you can go, if beam 28, all the way back out to Western Australia again, about as far as you can go. So your neighbours might have an extra 30 to 40 milliseconds difference in your latency speed. What's an extra 7,500 kilometres between friends, right? And if you're assigned to these, if you do have assigned one of these beams and it gets overpopulated, they might swap you across. And that takes about 10 minutes of no internet. It's not particularly efficient. Latency is pretty important for the things that we do online. For games, we want between 20 and 40 milliseconds, but we can get away with 100. Video calls, you want to be less than 200 milliseconds, otherwise you start talking over each other like crazy. Application UIs, you want to keep under 250 milliseconds, otherwise you just start to think that their application's broken. Skymuster is about 600 milliseconds, so it kind of breaks all of these things. So what does that mean to us? How are we going to build an application to service these conditions? Well, we write Ruby. We write artisanal, handcrafted, built with love and care Ruby applications. But like most red-blooded developers, we're also tempted by the new and shiny things that come along. So sometimes we chase the shiny things without considering the experience of our users, especially when those tools make us feel more productive. Speaking of which, have you met Turbo? The library lets you make even more server calls than ever without writing any JavaScript. Now don't get me wrong, I love the experience of developing Turbo. And some of our apps, some parts of our apps have even been built with this. If you want to remember our customers and their latency, so surely there's a definitive app that's done Turbo well, that we can take guidance and inspiration from. So this is an app that we've used a bit, and because of our diverse team, we've experienced the full range of timing with this. Quite often, I just want to open a menu and see what I've got going on. There you go. Plot twist, this was on my gigabit internet. It's not even the experience that our remote developers have. Thanks to American servers, that's amazing. I even tried Hey in the early days for a little bit, but I couldn't stand waiting between every click. It's also very easy on unstable connections to get mismatched state. Has anyone seen these before? Close a PR and it doesn't quite line up? So which is it? Our first prototype of the app was built in Power BI, the real one. And it just made it very obvious that clicking and waiting for the server to respond wasn't the experience that we wanted to provide. So you have to consider the user requirements before chasing the new shiny thing. Our biggest challenge was dealing with our users' SSI. So the NBN satellite has transfer speeds of about 25 down and 5 up. But according to nbnco.com.au, the satellites were designed to match this speed at least once a day. So thanks for the rest of the day, NBN. That 2 seconds was amazingly fast. And we have the base state, the latency, as we discussed before, and the reliability of things dropping out. New internet like Skylink can solve our latency problem to a degree, but at the moment, until we get a much bigger constellation, even the reliability is still a problem. This is our app. We have a lot of data that we need to send down, and it breaks it down into lots of different aspects. So clicking and dragging and filtering on one chart will affect what you see on the others. And this is experience that we didn't want just city users to be able to have. We wanted our actual farmers to use this system. Now, waiting was always going to be inevitable, so I wanted to make it at least cute. Also, sometimes you don't get data, and you get a sad cow. So some of the hurdles that we had to cover was limited bandwidth, latency, and unreliable connections. So we have a couple of different approaches that we can take to solve these things, using pretty straightforward and common web technologies. So one of the most obvious is to send fewer bytes. Most of our dashboards, depending on the customer, will have between 2,000 and 80,000 records that need to be sent down to provide this kind of interaction that we want. Just to say, these charts, we discovered fairly early on they needed to be rendered with Canvas, because who thought a browser couldn't handle tens of thousands of SVG elements? But our data looks like this. This particular sample goes on for about 6.5 meg of JSON. It's not something you really want to be pulling down a lot. So I thought surely there's a better data format that we could use to send this data down. It doesn't take long on Google to find message pack. Message pack is a very neat standard for kind of removing the cruft of JSON, being much more succinct. Fairly succinct. It's so pretty and easy to debug. Amazing. But in reality, it is a very well thought out protocol. But this only saved us about 1.5 meg. Cool. So we thought, okay, what if we just take the values? The common thing here was a lot of shared keys. This might be like shapes. So here we thought, okay, well, what if we just send down the values? Now this does have an overhead of if we want to change what values we send down, the front and back end have to agree on versions, and a little bit of extra developer complexity at this level. But the data's a lot smaller, right? Well, kind of. So it's definitely better, but it's not a huge improvement. Not the kind of improvement we were hoping for. And the next step, what if we could detect common attributes, common values? Maybe build a list of them, put them together, and rehydrate them on the other end. Surely someone has thought about this before. So compression using these libraries, thankfully, is very easy to put in place. You just got to remember to do it. And so we put these in, and the one thing to note about adding these in is if you have multiple middlewares, you want to put these in earlier. Because if any of your middlewares want to inspect the content of the page, if they've already been compressed, they just get garbled data. That was an interesting couple of hours of debugging that one. And so applying these was a massive win. It's like repetitive data, unsurprisingly, compresses very well. And so being able to go from 6.5 meg to 250 kilobytes was just the cheapest win that we've possibly had. And then adding the overhead of these other two different approaches, it was just easier to compress JSON.
Sorry, can you do that to anything, or is it
No, so the browsers have inbuilt support for both gzip and Brotli. And so you just need to have the header, they'll automatically send up. And so even Safari these days, since version 13, supports Brotli, which is a massive step forward. So you can implement this, and pretty much all the current browsers will just make your data smaller. So you want to send fewer bytes. We have cache headers. Rails calls these conditional gets, and they use the inbuilt HTTP technology of e-tags and caching headers. Whenever the browser requests a content, or requests a page, if it's seen it before, it will include an e-tag, which is essentially a small hash of the content of the page. If Rails has seen this before, it'll just immediately respond. If we wrap it in stale, it will immediately respond with a 304 not modified. And the browser doesn't have to pull that data again. It'll just use what it currently has. Now, this is great for sending down data expensive content, and is reasonably easy to implement on Rails. If you've done any fragment caching before, the invalidation approach is very similar. You just pass in the elements that you want it to check, and if they've changed, then they will. By default, it will use the updated at if you just pass a record in. But you can change the thing that you want to check the freshness of that record. So don't send data that you don't need to, if the browser's already seen it. And the last approach, service workers. It's a little bit more of a scary concept. But service workers, you can kind of think of like a CDN, where we try and put our content as close to the users as possible. So we take them from our server, save them on the CDN. Caching headers are also fantastic for this. The CDN doesn't even have to hit your server sometimes. But what happens when the satellite breaks? CDN's not particularly useful then. You can think about service workers as a kind of CDN on the browser. It gives you the ability to intercept network calls and choose what you're going to do. There's a couple of common approaches you can use to CDNs, to service workers. You can do cache only, network only. These two are a little too restrictive for our needs. The Chrome developer docs have some really useful and in-depth introductions as to how to use these things. One common approach is the cache first, falling back to the network. If you have data that you know is very unlikely to change, you can just go straight and say, hey, do I have this? Have I seen this before? And if you have, just use it. And only if you don't, go to the network, grab a copy, and use that from then on. It's a fairly limited use case, but it can be very handy. The next approach is to try and hit the server, and if the server's unavailable, say the satellite's down, whatnot, use the version that you already have in cache. This is great for someone who's booted up a session of your app and is using it and just gets a temporary drop. They'll still get a response. It might not be quite up to date, but there are ways of detecting this and showing the user you're offline, etc. Another very useful approach is to stale while revalidate. And this one gives you an immediate response. You can hit the server, your browser makes the request, you immediately respond with what you have in cache, but then you also go to the server and say, hey, do I have anything new? If you don't, then you're all good. And if you do, you pull that down, update the cache, and then you can notify the app to reload the data. This gives a fantastic responsive interface for our users, as well as making sure that they have the newest data. You can learn lots more about service workers at these resources. So the third aspect is adding resilience to your app to make it handle it. Because when you make your app better for Gloucester, you make it amazing for Melbourne. Surprise, and this is an accessibility talk. There's many things you can do to target the people that have it, that find that your system doesn't serve the best. Optimize for them, and it will always be better for everybody else. This is not sponsored, but a shout out to Linear and an amazing app. It's a ticketing app which has a fantastic development team. They have their app essentially designed to work offline first. And then there's a syncing layer in the back that takes care of making sure that everything's up to date. We have, like, regardless of where we are, which of our developers around Australia, this responds immediately, saves immediately, and is just a dream to use. Take inspiration from it every day, as well as my next task. So if we have a limited bandwidth, sending fewer bytes, with latency and bandwidth, we want to kind of limit what we send, and adding resilience to an unreliable connection. So creating an app that has, so some things to remember. When you're creating an app, you don't need to necessarily choose the most shiny thing. At the moment, there seems to be a bit of a trend to talk down and against single-page apps and to do as little JavaScript as possible. Everything's a pendulum, back and forth, back and forth. But it's important to consider your customers, their needs. Sometimes a single-page app is the right solution. When it comes to this, it's important to make sure that if you are writing a single-page app, never break the URL. URL is important. JavaScript can easily break accessibility. To try and avoid creating your own framework on top of a rendering library. It's just a recipe for disaster. And I know that you all appreciate building apps based on conventions. That's why we're here. We love Rails. So if that kind of mentality resonates with you and you want to build more on your front end, I'd recommend checking out Ember.js. But thank you very much.